Algebra 2, Lesson 2.2a, Graphing Quadratics in Vertex Form. All right, there are some properties, all right, of a quadratic that you need to know, all right, that are very important. So when we graph y equals x squared or y equals negative x squared, right, we get this U-shaped figure, right? So this is called a parabola, okay? When it's a U, we say that it opens up, right? When it's an upside down U, we say that it opens down. Okay. Now, the vertex, or we talked about the vertex last lesson. So the vertex in this case here, it would be 0, 0. Those would be the coordinates. The vertex is a point, so it has coordinates, right? So over here, it's also 0, 0. Now, if I draw an imaginary line going straight through the vertex, what it would do is it would split the parabola in half, right? It would cut it in half, right? So this line here has a name. It's called the axis of symmetry. Okay. Now, when you want to find the equation of this line, you notice the axis of symmetry, it goes through the vertex. So the equation for the axis of symmetry is the same thing as the x value of the vertex, right? So when you're asked for the equation for the axis of symmetry, it's the same as the x value of the vertex. So the x value of the vertex is 0, so you would say the equation for the axis of symmetry, you would say x is equal to 0 if you're asked for that equation, right? If you're asked for the equation for the axis of symmetry. Same thing here, if I draw an imaginary line going through the vertex, the axis of symmetry, right? The equation, right? Well, it's going through 0, right? That's the x value of the vertex. So the equation for the axis of symmetry would be x equals 0. Okay. Sometimes I'll abbreviate the axis of symmetry AOS. All right. A few other things that are really important. When a parabola, when the vertex is the lowest point, so for example here, where the vertex is the lowest point, we say that the quadratic has a minimum value. Right, so when the quadratic, right, when the parabola, the vertex is the lowest point, we say that the quadratic has a minimum value. When the vertex is the highest point, we say the quadratic has a maximum value. Right. Now, so if you think about it, what determines if a parabola opens up or down? Because that's what tells you if the vertex is going to be the lowest or the highest point. And that's the a value. So you will have a minimum value, right, when a is positive. You will have a maximum value when a is negative. Okay? Now, if you want to actually find the value, the number, what is the number? Okay? The minimum or maximum value, right? So the minimum or maximum value is the y value of the vertex. Okay, it is the y value of the vertex. Okay. All right, so now that we have that knowledge, let's fill in these blanks here in your notes. So the axis of symmetry is a vertical line that crosses through the vertex, right? So it crosses through the vertex and splits the parabola in half. Okay. A quadratic will have a minimum value, right? So let's think about it. When the vertex is the lowest, that's when it will have a minimum value. So when does a parabola look like this? Well, that's when a is positive, right? A quadratic will have a maximum value. So it will have a maximum value. It will be, the vertex will be the highest when it's upside down. And what makes it upside down? When there's a reflection in the x-axis. So that's when a is negative. The axis of symmetry is equal to, so whenever you're asked for the equation for the axis of symmetry, it's equal to the x value of the vertex. So the x value of the vertex. Okay, so whatever the x value of the vertex is, that's the equation for the axis of symmetry, right? one thing, make sure you don't just give me a number. The axis of symmetry is a vertical line, so make sure you give me x equals that number, okay? The minimum or maximum value, okay? So A tells you if you will have a minimum or maximum. Now, if you actually want to find the value of the minimum or maximum, all right, it's the y value of the vertex. It's the y value of the vertex, all right? All right, so now let's talk about vertex form, right? So you guys should be familiar with this. We explored vertex form in the previous lesson. The y equals a parentheses x minus h squared plus k. So this has a name now, right? This is called vertex form, okay? Last lesson, when we explored the a, h, and k values, right, you guys didn't know what this equation was called, right? So this equation here is called vertex form. Now it's called vertex form because if you just look at the equation, you should be able to find the vertex. Now remember, the vertex is going to be the h and the k values, and we know how to find that, okay? So let's take a look at these quadratic equations on the bottom here. Let's find the vertex for each one, okay? Now, if we need to find the vertex, right, for this first one here, now remember, if you recall, I told you that for the x value of the vertex, right, you have to do the opposite of what's inside the parentheses. So remember, we always did the opposite for h. So if it's minus 8, that means x is positive 8. And then the k value is 5. So the vertex is 8 comma 5. Okay? So the vertex for the next one, it would be negative 6 comma negative 2. Now this one's a little bit tricky. You kind of have to understand that this equation can also be written y is equal to 4 parentheses x minus 0 squared plus 5. So if you understand that, you'll know that the vertex would be 0 comma 5. Okay. Over here, next one, vertex, opposite inside the parentheses, so negative 1 comma, and then the k value is 0. Okay. Vertex for the last one, we'll get positive 9 comma negative 3. Right? So that's why it's called vertex form, because if you actually just look at the equation without doing any work at all, you should be able to find the vertex and state what it is. All right, so let's take a look at this example. Now let's say we need to graph, right? Let's say we're going to graph this quadratic that is in vertex form, okay? So in order to do that, the first thing you want to do, right, I'm going to put some steps over here. So step 1, you want to find the vertex. So over here, so the vertex we know is going to be, well, the vertex, I know is going to be positive 5 comma negative 1. Okay, so you want to find the vertex and then plot the vertex. So 5 comma negative 1. So positive 5 comma negative 1. So here's the vertex right here. The next thing, right? So step 2, you wanna find one other point to the right and to the left of the vertex, okay? And the easiest way to do that, right, is to use the a value. So what you're gonna do is you're gonna use the a value to find one other point to the left and right of the vertex. All right, so here's how you do it. So I know in this case here a is 3. So I know a is equal to 3. Okay. Now if a is positive, that means we move up. If a is negative, we move down. So here's how you find another point to plot for your graph. So from where the vertex is, right, you're always going to move to the side one time. So I don't care if you move left or right now. So let's say I'm going to move to the right one time. Okay. And then if a is 3, that means that we're going to move up 3, right? So 1, 2, 3, and then that's where your point will be. Now, since a parabola is symmetrical, you could do the same thing to the left side or the right side, right? So the left side here, we move to the left once, we're also going to go up 3. So, and then this is our parabola. Okay, so when you guys are sketching, I should see where your vertex is at, and I should see one additional point to the right and left of the vertex. Okay, and we find that point by using the a value. All right, there's other ways to find an additional point. You can make an x and y table, but the easiest way is to just use the a value. Okay, so quick review from the vertex: always move to the side one time, so you're always going to do that. And then whatever a is, if a is positive, you're going to move up that many times. If a is negative, you're going to move down that many times. All right, so let's take a look at another example. All right, so number 2 here. So we're going to graph this, right, quadratic. So we're going to find the vertex. I know the vertex is -2, -1. And then I'm going to plot it. So -2, -1. So here's my vertex. Okay. And then I know the a value is -1, so a is equal to -1. So what that means is, from my vertex, I'm going to move to the side one time, because I always do that. And then if a is -1, that means I'm going to go down 1. I'm going to go down 1. I'm going to do the same thing to the left side. Move to the left once, a is -1, I go down 1. And then I just sketch my parabola. Okay. And you notice everything makes sense. You know that when a is negative, the parabola is supposed to open down, right? Because there's going to be a reflection. Okay, let's try another one. All right, so let's take a look at this example. So my vertex is -5, -4. Okay, so I'm gonna plot my vertex, -5, -4. So here's my vertex, right? What's the a value? So a is half, right? So from your vertex, right? Remember, you're always going to move to the side one, right? So you always could move to the side one time. So from my vertex, I'm going to move to the side one time. It doesn't matter right or left. And then if a is half, right, that means I'm going to move up or down that amount. So since a is positive, I'm going to go up half. So I'm just going to go up half a unit, right? So up half, so I'll be right there. So same thing, move to the left once and up half. Then you know this parabola is going to be kind of wide. As you remember from the last lesson, when a is a fraction, right, less than 1, the parabola will get wider. Okay. All right, so let's take a look at the a values and how it affects the graph. Right, and we kind of already know this because we talked about this in the last lesson, but let's review it. So over here, a is 1, a is 2, and then a is 5. So you have to remember when the absolute value of a, right? So just ignoring positives and negatives right now. The absolute value of a is bigger than 1. The graph gets more narrow, right? And remember, so the graph will get more narrow. And remember, we call that a vertical stretch. Over here, when a is half, or 1/10, right? So when a is a fraction less than 1, right? So when a is a fraction less than 1, so when the absolute value of a is a fraction less than 1, meaning it's between 0 and 1, right? The graph will get wider, right? The graph will be wider. And we call that a vertical shrink, right? And then over here a is positive, and over here a is negative. And remember, if a is negative, right? If a is negative, we have a reflection. The graph will flip, right? It'll flip. Draw a better parabola. And we call that a reflection in the x-axis. Okay? So let's summarize everything we just talked about, right? So if the absolute value of a, right, is greater than 1, so if the absolute value of a, right, so the absolute value of a is greater than 1, the quadratic, it's going to be more narrow. So remember what we call that, the quadratic has a vertical stretch. Right? Because it will be more narrow. If the absolute value of a is between 0 and 1, right, the quadratic has a vertical shrink. Okay. If the absolute value of a, right, is 1, so if a is actually 1, right, it doesn't matter if it's positive or negative. If a is actually 1, then we consider it just the normal graph. So we say it neither, all right, the quadratic has neither a stretch or shrink. All right, so there isn't a stretch, there isn't a shrink either, because it's just 1. If the a value of a quadratic is negative, so if a is negative, the quadratic will reflect in the x-axis. All right, so we've got a lot going on here. So let's take a look at part A. It says find the coordinates of the vertex. So I know the vertex is going to be 2, 4. So I'm going to plot it. So 2, 4, 2, 4. Okay. Then it says plot one additional point to the left and right of the vertex, then sketch the quadratic. Okay. So remember, we can find that extra point using the a value. So I know a is 3. So that means if I move to the side one time, I will go up 3. 1, 2, 3 from where my vertex is at. So from where your vertex is at, just move to the side one time and go up 3 because a is positive 3. Then it says to sketch this. Okay. So we've just sketched the parabola, right? Part C says graph the axis of symmetry and state its equation. So remember, the axis of symmetry goes through the vertex. So I'll make a little sketch, just make a dashed line going through the vertex. So there's the axis of symmetry, right? So graph the axis of symmetry and state its equation. So the axis of symmetry, right, we're gonna have x equals, and then what's the x value of the vertex? 2, right? So right here, the x value of the vertex is 2, the axis of symmetry is gonna be the same thing. But make sure you tell me x equals 2 and don't just give me the number, okay? State the minimum or maximum value. So first of all, the vertex is the lowest point, so we know we have a minimum, right? So the minimum value is equal to, that's the y value of the vertex. The y value of the vertex is 4. So you just say the minimum value equals 4, like that. Does the quadratic have a shrink, stretch, or neither? Well, if a is 3, that means that the quadratic, right, the parabola gets more narrow. So remember, that's going to be a vertical stretch. So we're going to have a vertical stretch, right? Because a is equal to 3, right? 3 is bigger than 1. And then the last part, is there a reflection? Well, a is positive, so there's no reflection, right? So there's no reflection. Okay, so that's all it's asking for. So just take everything step by step. It's not too complicated, right? All right, so let's do another example similar to the last one. So I'm gonna find all the same things. So the first thing I'm gonna find is the vertex, right? So I know the coordinates of the vertex is gonna be -4, -2. So I'm gonna plot that, -4, -2, okay? Next thing, we need to find one more point to the right and left of the vertex. So I'm gonna use the a value. So I know a, in this case, if you don't see an a there, you can pretend there's a 1. So a is equal to 1, right? So I'm always going to move to the right and left one time. And if a is 1 and it's positive, that means I'm just going to go up 1, right? So I go up 1. Then I'll sketch my parabola, okay? Next thing, we want to sketch the axis of symmetry. So the axis of symmetry, this is an imaginary vertical line that goes through, right, the vertex. So the axis of symmetry, we're say the equation is x equals, and remember, it's the same thing as the x value of the vertex, -4. Okay. Now, does this graph have a minimum or maximum? Well, the vertex is the lowest point, so we know we're going to have a minimum value, and the minimum value is the same as the y value of the vertex, -2. Okay. this graph here, is there going to be a vertical stretch, shrink, or neither? Well, if A is 1, there's no stretch or shrink. So neither stretch or shrink. Then the last thing, is there a reflection? Well, A is positive, so the graph doesn't flip. So there's no reflection. Okay? So when you guys see an equation in vertex form, you should be able to identify and understand all these kind of properties of the parabola. Okay? All right, so let's take a look at this last example. So it says find the vertex first. Okay, that's easy. We're going to have 4, negative 5. Okay. The axis of symmetry. The axis of symmetry is the same thing as the x value of the vertex. So we know where say x equals 4. Does it open up or down? Right? Well, A is negative 1. If A is negative, we know the graph is going to flip like that. We know it's going to open down. All right. Because A is negative. Okay. I'm just explaining it so you understand why. Do we have a vertical stretch, shrink, or neither? Well, when the A value is actually 1 or negative 1, it doesn't stretch or shrink, so that's going to be neither. And then, all right, does it have a reflection in the x-axis? Yes, it flips, right? A is negative, so yes, there is a reflection in the x-axis. Right?